Last week you chose as the 6th the element of erbium, and since it took so long to pick this element, my question was, how important is this element and could we live without it? Now imagine a world without high-speed internet, clear phone calls or certain life-saving medical lasers. Sounds dramatic, right? What if I told you that a little-known element on the periodic table plays a huge role behind the scenes in all of those things? And that element is erbium. Most people have never heard of erbium, and if you have, congratulations, you're a true chemistry fan. But for everyone else, erbium might sound like, what now? Don't worry, by the end of this video you will not only know what erbium is, but also why it is important in your daily life, more than you have ever imagined. Welcome to Cube Chemistry, where we will discuss all the elements of the periodic table and also do experiments. And if you like this video and you want to see more, make sure to like, subscribe and comment on the video. Also, make sure to fill in the poll so you can influence what element we will be discussing next week. So what do we got here? Well, we got another silvery gray metal. Now, if you compare the gray with some of the other silvery gray metals that we have, you can see slight variances. But I think we can safely say that the periodic table contains 50 shades of gray when it comes down to metals. Now, like always, if you want a piece of this rare earth metal, because that's what erbium is, you can go to Engineered Labs by clicking on the link in the description and make sure to use the promo code and you can get a 10% discount. And you will also be helping out this channel. Our story begins in a quaint village called Ytterby in the early 1800s. And believe it or not, this village would become legendary amongst chemists. In 1843, a Swedish chemist named Carl Gustav Mosander, which we have discussed in previous videos, was studying a mineral ore from Ytterby. Now this ore was thought to contain an element called yttrium, but Mosander had a hunch that there were more treasures hidden inside of it. He was right. By carefully separating out the parts of the ore, Mosander discovered that what people thought was a single substance was actually a mix of several different materials. Now in that mix he identified two new mysterious oxide, chemical compounds containing a metal and oxygen. He decided to name these two new substances erbia and terbia. Now the names might sound a little bit odd, but he chose them as a nod to Ytterby. He was basically chopping up the village name to coin new element names. Mosander's discovery was the beginning of a long adventure in chemistry. Now back in the 19th century, separating and identifying rare earth elements, the family erbium belongs to, was really tricky. These elements have very similar properties, so scientists often got them mixed up. Now after Mosander's initial discovery, other chemists kept investigating the same Ytterby ore and found even more elements hiding in there over the years. Elements like thulium, holmium, ytterbium, gadolinium. It was as if Ytterby was the gift that kept on giving to the periodic table. But with so many new elements popping out of the same source, you can imagine there was a lot of confusion. Now one particularly funny mix-up happened in the names of erbia and terbia. These two names were so similar, just swap a couple of letters, that scientists in different countries flipped them around by mistake. At one point in the 1860s, the substance Mosander called terbia was being referred to as erbium, and what he called erbia became terbium. Confusing, right? It's like a classic comedy of errors. The chemical version of accidentally swapping identical twins. This naming confusion persisted for years. Now finally, by around 1877, the issue was sorted out and the names were fixed to what we know today. Erbium, with the symbol ER, and terbium, with TB, became two distinct elements. So, if you ever found the names of these elements a tongue twister, rest assured, even scientists back in the day were tongue-tied by erbium and terbium. Now, despite it being discovered in the mid-1800s, isolating pure erbium was another challenge that took decades. It wasn't until 1905 that two chemists working separately in France and America managed to isolate a relatively pure sample of erbium oxide. That's erbium combined with oxygen. Now, what about the pure metallic form of erbium? Well, that had to wait even longer, till 1934, when researchers finally extracted the pure metal by clever chemical reactions. They used a tricky method of reducing erbium chloride with potassium vapor, essentially stealing the chlorine away and leave just the metal. Imagine that, from 1843 till 1934. It took nearly a century from discovery to pure metal, but eventually erbium took its rightful place on the periodic table as a defined element, no longer hiding in a mix of other substances. Now that we've entangled the discovery story, let's talk about that peculiar name, erbium. Where does it come from? Well, as hinted earlier, the name is a tribute to the Swedish village of Ytterby, a place so famous in chemistry that it lent its name, or parts of it, to not one, two, but four different elements. Erbium is one of those four. In fact, if you listen closely, you can hear Ytterby echoing in yttrium, terbium, erbium, and ytterbium. It's like Ytterby had quadruplets and gave each a variation of its name. This little village mine was such a hot spot for finding new elements that scientists essentially said, well, we found another one here, let's just scramble the letters together of Ytterby and see what we get. So erbium got the erb from the middle of Ytterby. Terbium took terp. Ytterbium basically stole the full name, and yttrium got iter. It is a fun bit of trivia to think that a single small town has so many elemental namesakes. Talking about leaving a legacy. Now, aside from its origin, the name erbium doesn't have a deeper meaning in Greek or Latin. Unlike some of the other elements named after mythological figures or properties, it's pure geographical. But that in itself is pretty cool. It forever links the shiny metal element to the spot on the map. And in case you're wondering, the symbol for erbium, ER, well, it just makes sense. No fancy alphabets or odd letters, just E and R. Nice, plain, simple. Though saying out loud may sound like you're hesitating or trying to remember something. Erbium? Now let's move on to what erbium actually is. If you had a chunk of pure erbium, like in this cube, what would you see? Well, erbium is a silvery white metal, like we explained earlier before, with a bright metallic luster when freshly cut. It is quite striking, shiny like silver, but it's not a precious metal. In terms of feel, it's relatively soft and malleable. Now, if we had the metal outside of this cube, we could probably dent it or cut pieces of it with a knife. Not that we recommend hacking up expensive rare metals for fun. This softness is typical for metals in erbium's family, the lanthanides, also known as rare earth metals. Now, they're called rare earth metals not because they are extremely rare in the Earth's crust. Erbium is actually more common than silver and gold, but because they were rarely found in its pure form historically. Kind of like scandium a couple of weeks ago. And they're really tricky to separate from each other. So erbium's a soft, workable metal. Think of it as a opposite of something like tungsten, which is super hard. Erbium won't win any strength contests among metals. One good thing about erbium is that it's relatively stable in air. Some metals, especially some of the rare earth cousins, tarnish or rust quickly when exposed to air. For example, if you leave a piece of lanthanum or cerium out, it might corrode within hours or days. Erbium, by contrast, takes its time. It will slowly lose its shine as a thin layer of oxide forms on its surface, but it doesn't fall apart or crumble. Now, in plain terms, we can say that erbium doesn't explode or catch fire on contact with air or water. It's not one of those dangerously reactive metals. However, it is still reactive enough to remind you that it's not a noble metal like gold. If you drop a piece of erbium into water, nothing will happen immediately, especially if the water is cold. But it will gradually react, producing tiny bubbles of hydrogen gas and forming erbium hydroxide. It's a slow fizz, not an explosive reaction. You have to watch patiently to even notice it. And if you put erbium in acid, say dilute hydrochloric acid, it will react more vigorously, dissolving and releasing hydrogen gas. So yes, erbium behaves like a typical active metal. It corrodes and it reacts, but moderately so. Now, one of the coolest properties of erbium is actually its interaction with light, and it shows up in the form of color. Erbium in its metallic form is just silvery, but when erbium forms compounds, they often have a distinctive color. For instance, erbium oxide, Er2O3, which is essentially rust of erbium, is a beautiful pink color. Not many elements give a pink compounds, so erbium stands out. Now, if you see a piece of erbium oxide or erbium salt in a chemistry lab, It might have a faint rosé or lavender tint. In solutions, erbium ions can impart a light pink color as well. It's almost ironic. This burly sounding metal, erbium, has a bit of a rosy, feminine side when it comes to its chemistry. This unique pink signature is like erbium's calling card and actually is used in some practical applications, which we'll get to soon. Now, aside from the color, erbium has some very interesting high-tech physics behavior. For example, at very low temperatures, way below the freezing point of water, more like closer to absolute zero, erbium's magnetic properties change. At room temperature, erbium is what scientists call paramagnetic, meaning it's weakly attracted by magnets, but not magnetic by itself. In other words, you can't stick erbium to your fridge door like you would be able to with a normal magnet. But if you cool erbium down to about minus 270 degrees Celsius, just a few degrees above absolute zero, it becomes ferromagnetic. It can start to behave like a magnet. You can think of erbium as getting magnetically excited when it's super cold, whereas at warm temperatures, it's pretty chill. Yeah, pun intended. For our purposes in everyday life, this doesn't matter much, but it fascinates scientists and is useful in some niche low-temperature technologies. Now, let's get to the most important property of erbium, in my honest opinion, the one that makes it technologically invaluable. It is how it interacts with infrared light. Erbium atoms, when energized, for example by a strong light or an electric current, can emit light at a very specific wavelength in the infrared region, around 1.5 micrometers to be exactly. Basically, erbium can glow in infrared at just the right color that we also use for fiber optic communication. This is super special, because that wavelength of light travels through optical fibers with very low loss, meaning the signal stays strong for a long distance. Not many materials emit exactly at that sweet spot of wavelength. So that's what brings us what we actually do with erbium. Why do people mine it and refine it? It turns out that erbium's unique traits make it a real MVP in several areas of technology and industry. One of the biggest and arguably the most crucial uses of erbium today is in fiber optic communication. Think of the vast network of glass fiber cables that span continents under our ocean and across cities. These carry the internet to all of us as pulses of light. Now, as light travels over these ultra-thin glass fibers, it tends to weaken over long distances, just like a flashlight beam fades with distance. We need to boost the signal periodically so it can keep traveling. Instead of converting the light to electricity and then back, which is inefficient, scientists have found a better solution: erbium-doped fiber amplifiers, often abbreviated as EDFAs. So here's how it works in simple terms. A small section of the fiber is doped with erbium, meaning a tiny amount of erbium ions are embedded in the glass. When the faint light signal reaches the erbium-doped section, we shoot a second light from a pump laser into it as well. The erbium atoms absorb the pump laser's energy and then release it by amplifying the original signal light. Remember the perfect wavelength emit at 1.55 microns? That's the telecom signal wavelength. The result, the once weak signal emerges from that fiber section much stronger, without ever having to leave the fiber. Now, these erbium amplifiers are the unsung workhorses of the internet. They sit in the optical repeaters every 50 to 100 kilometers alongside those fiber routes, quietly boosting the signals. Without erbium, long-distance fiber optics would be way more complicated and expensive. Or we'd rely on slower methods. So every time when you stream a Netflix show, join a Zoom call, or yes, even watch this video, erbium is likely helping that data reach you. Think of erbium as the caffeine boost for your internet signal, a little pick-me-up that keeps the information going. It's pretty amazing that an element discovered in 1843 is now the pillar of 21st century communication. Now, erbium's love affair with light continues in the realm of lasers. You might have heard of laser types like ER-YAG, erbium-doped yttrium aluminum garnet, or ER-glass lasers. These are lasers where erbium is the active element that produces laser light. For instance, ER-YAG lasers are widely used in medicine and dentistry. Now, they can precisely vaporize or ablate tissue with minimal heat damage to surrounding areas. Translation: they make amazingly precise cutting tools for surgeons and dermatologists. If you heard of laser skin resurfacing treatments for wrinkles or scars, etc., or certain types of laser surgeries, those often use erbium lasers. Now, dentists have experimented with erbium lasers to drill cavities without the need for a traditional drill. Imagine getting a filling with a laser zap instead of that whining drill sound. Yes, please. These lasers are effective because the water in our tissues strongly absorbs the erbium laser light, causing instantaneous vaporization of tiny layers of tissue. It's like peeling an onion, one super thin layer at a time, which is perfect for fine, controlled work. Now, beyond medicine, erbium lasers also show up in other fields. They're used in some rangefinders and LiDAR systems, which are like laser radar. Because erbium's wavelength can be eye-safe under certain conditions, the cornea absorbs the beam, so it doesn't reach the sensitive retina. Even the military has employed erbium lasers in things like laser designators or range-finding binoculars for the same reason. You don't want soldiers accidentally blinding themselves with reflective laser light, so an eye-safer wavelength is preferred. In telecommunications, erbium-doped fiber lasers are a thing too. Basically combining the fiber amplifier idea and lasers to create stable lasers for lab use or even manufacturing. Now, from high-tech to fine arts, erbium also has a role in making things look pretty. Remember that lovely pink color of erbium oxide we talked about? That property is used to tint glass and ceramic glasses. Erbium oxide or other erbium compounds are added in small amounts to glass mixtures to produce a delicate pink or rosé-colored glass. Now, you might have seen decorative vases or the lenses of certain sunglasses or glazes on porcelain that have a subtle pink hue. That could very well be thanks to erbium. In fact, pink tinted sunglasses often use erbium because it can absorb some UV and infrared light while giving that rosé tint. Fashionable and functional. Now, erbium also finds its way into the field of metallurgy, the science of mixing metals to make alloys with better properties. An interesting example, adding a tiny bit of erbium to vanadium, a metal used in steel alloys and nuclear reactors, can make vanadium alloys easier to shape and less brittle. In essence, erbium can act like a softening agent in some alloys, improving their workability. Now, another metallurgical use is in specialty zirconium alloys for nuclear reactors. Now, we've touched upon it a little bit in the zirconium episode, you can see it here, but erbium can be added to these alloys as a erbium-containing mix to help control how the material behaves in a reactor environment. Certain isotopes of erbium are very good at absorbing neutrons. In a nuclear reactor, controlling the number of neutrons is crucial for maintaining a steady chain reaction. Too many neutrons flying around can make the reactor go supercritical. Too few and the reaction fizzles out. Now, substances that absorb neutrons are called burnable poisons in reactor terminology because they poison the chain reaction initially and then slowly get used up or burn away. Erbium, often in the form of erbium oxide, Er2O3, sometimes called erbia, can be mixed into nuclear fuel rods as a burnable poison. So, why do we do that? Well, when fresh nuclear fuel is loaded, it's super reactive. Lots of neutrons would go crazy if not managed. Erbium soaks up those extra neutrons at the start, keeping the reaction in check. As the fuel rod burns over the months, the erbium itself gradually gobbles up the neutrons and transmute into other elements, losing its effectiveness. Which is fine because by then the fuel's natural reactivity has dropped. This way the reactor runs more smoothly and effectively over time. Now this is a little bit like adding a slow melting ice cube to a hot drink to cool it initially, and then get the ice to gradually melt away as the drink settles to the perfect temperature. Not every reactor design uses erbium this way. There are other elements like gadolinium that are also used. But some do, especially certain submarine reactors or power reactors where long fuel life is desired. It's a very behind-the-scenes role. If fiber optics was the flashy job, this is the quieter caretaker role for erbium. Now beyond the big categories above, erbium pops up in a few other interesting places. For example, erbium-doped materials are used in upconversion phosphors. These are special materials that can take in 2 low-energy photons, like infrared light, and emit 1 higher energy photon like visible light. Now such materials have niche uses in things like biomanaging or anti-counterfeit ink, in money or documents. Erbium's optical tricks make it useful here as well. There's also research into quantum computing and photonics, where erbium atoms in crystals might serve as quantum bits or memory that interface well with fiber optic networks. Now you'll probably be thinking, okay, erbium is cool, uses are high-tech fields, but how does it affect me? Well, the truth is, erbium's impact on everyday life is mostly behind the curtain, but very real. Everyday technology, as we know it, would not be the same without it. So, first and foremost, consider your daily communications. Every time you use the internet, make a phone call that travels through fiber lines, send an email, stream music or video, you are benefiting from global fiber optic networks. And, as we've learned, erbium is the silent helper that keeps those networks running efficiently. So, all those conversations, fast streaming, instant cloud data, reliable long-distance communication, erbium is part to thank for them. It's not as visible as, say, silicon chip in your phone or the lithium in your battery, but it's part of the hidden infrastructure. In a way, erbium is one of the unsung heroes of the information age. So erbium matters in everyday life, not in a you can survive without it way, but in our modern lifestyle would simply be not the same kind of way. So as we conclude our exploration of erbium, take a moment to appreciate how remarkable this element's journey has been. It started in a Swedish mine discovered by a curious chemist who literally had to sift it out of another element. It went through an identity crisis with its sibling terbium, causing confusion for decades. Eventually, erbium established itself with a clear name and identity just in time to become a key player in technologies that no one in the 19th centuries could have even dreamed of. Now, from enabling the fiber optic communications that form the backbone of the internet, to advancing medical lasers that improve people's health, to coloring glass with a distinct pink charm, erbium has proven itself to be incredibly versatile. So, the next time you are enjoying a binge watch session of this channel with smooth streaming, or you hear about a friend's successful laser treatment, you know there's a hidden helper to thank. Now, if you think I missed anything, and leave it in the comments. And if you like this video and want to see more, make sure to like and subscribe.